डियर ऑल वेलकम बैक टू द डिक्स्ट्रा एल्गोरिथम। सो आज की सेशन में हम डिक्स्ट्रा एल्गोरिथम को समझेंगे, डायग्राम एंड आर्किटेक्चर को समझेंगे, देन मैथमेटिकल टर्म्स को हम गेन करेंगे। उसके बाद हम उसी कंसेप्ट को कोर्स में कन्वर्ट करेंगे। सो लेट्स स्टार्ट द डिक्स्ट्रा एल्गोरिथम। Okay. So in the Dijkstra algorithm, first we try to understand what is Dijkstra algorithm. ये जो Dijkstra algorithm है, this is nothing but the shortest path algorithm. Previously in previous session हमने देखा कि shortest path algorithm में कैसे हम एक ग्राफ को कनेक्ट करते थे, like this. Graph might be connected like this, the paths like this. So ग्राफ के अंदर interconnections हो सकते हैं और उन सारे interconnections के थ्रू we try to reach from the source. We try to reach from one position टू अनदर पोजिशन विद द मिनिमम डिस्टेंस। मतलब बहुत ही कम डिस्टेंस में हम किसी एक सोर्स से डिस्टेंस से हम डेस्टिनेशन तक पहुंचने की कोशिश करते हैं। इसके लिए जो एल्गोरिथम से दीज आर द मिनिमम शॉर्टेस्ट एल्गोरिथम। सो व्हेनेवर वी गेट अ केस ऑफ वेटेड, मतलब सपोज दिस इज अ ग्राफ लाइक दिस, सो दीज आर द कनेक्शंस, दैट आर द कनेक्शंस। सो हमें जब भी ऐसे ग्राफ मिलता है कि ग्राफ के पास खुद की वेट है, सो लेट्स से इट इज 0 से 1 रीच करने में इट विल टेक 5, इट विल टेक 8, इट विल टेक 10, इट विल टेक 15, इट विल टेक 20। सो कैन यू सी ये जो ग्राफ है दैट आर हैविंग वेट्स, इन सब के पास एक एक वेट है। सो व्हेनेवर वी गेट अ ग्राफ जिसकी खुद की एक वेट हो, दैट मीन्स वेटेड ग्राफ हो। सो वेटेड ग्राफ में अगर हमें मिनिमम डिस्टेंस कैलकुलेट करना है, देन वी अप्लाई द डिक्स्ट्रा एल्गोरिथम। सो टू कैलकुलेट द मिनिमल डिस्टेंस इन वेटेड ग्राफ, to calculate the minimal distance in weighted graph, minimum distance in weighted graph, we use the Dijkstra algorithm. We use the Dijkstra algorithm. Dijkstra algorithm. So let's study that what this Dijkstra tells. Before we study, let's see example. Suppose that is the node 5. That is the node, let's say this 0 node, the starting node, and here it's a node like this, and this is the second node, let's say 1, and that is the second node 2. So whenever we start like this, whenever we get a track like this, we apply like this. Suppose this distance we get, that is 0, and in Dijkstra whatever the distance that is, मतलब जो भी हमें दिखा नहीं देगा, will be taking as infinity, that is infinity, that is infinity, and that distance we'll be calling, let's say this is 5 and this is 10. So what we do in Dijkstra is typically greedy algorithm. मतलब greedy में होता क्या, one by one each step and each step. So that's it. So हम Dijkstra में this position, initial position से final position तक पहुंचने की ले ट्रैक करेंगे. So this is 0 plus 5. हम चेक करेंगे अगर 0 जो भी पाथ का इनिशियल वेट है और ये जो एज है, इस एज का जो वेट है, दैट इज इफ लेस देन टोटल दिस वन, दिस इज इन्फिनिटी। इफ दैट इज लेसर देन हम अपडेट कर देंगे, सो इट विल गेट अपडेटेड, सो इन्फिनिटी विल गेट 5. So let's take another example. This is u and that is v. So again, if we try to reach from this u position to v, so you see u, that is 5, it is having 5 and the path is having 10. So u plus 10, that is 5 plus 10 less than v. So v is infinity, that means it is always lesser. So what we do, we update it, so infinity will get cut and will be updating by 15 the total distance. So that is how we update in Dijkstra algorithm. So that is the Dijkstra algorithm. So that is the Dijkstra algorithm that we update one by one step. So आज की सेशन में हम जानेंगे कि कैसे one by one through codes हम each session हर चीज को implement कर पाएंगे in Java. So let's try to understand. Dijkstra algorithm find the shortest path from a source node to all other vertex. As I told you that it always try to find the shortest path, सबसे छोटा path ट्रैक करने की कोशिश करेगा. सपोज दिस इज अ कनेक्टेड ग्राफ, डेंस ग्राफ, दैट मीन्स all nodes are connected to each other, all nodes are connected to each other. So in Dijkstra it will try to find the shortest, let's say it will try to find the shortest 0 to 4 like this in a weighted, rated or unrated graph. So this is weighted, that means in Dijkstra graph में weight होना ही पड़ेगा, that must be weighted. That means ये जो weight देख सकते हैं आप, this is a weighted graph. Directed, that means it might have a direction, or undirected, that means if a graph is without any direction like this, it has no direction, then also Dijkstra might be applied. Now how we can implement the Dijkstra, ये जो Dijkstra का algorithm से उसे हम कैसे implement कर पाएंगे. So first इसके लिए we have to create a graph representation, and for creating the graph representation we'll be using adjacency list. So first we have to create a, this is same आपने जो previous session में, if you have watched the last video, shortest path algorithm, what we have used, हमने shortest path algorithm में we have used the distance array. This is the distance array. So we'll be using same distance array we'll be using in this video also, and in last session in shortest path algorithm we have used queue, लेकिन हम यहाँ पर queue नहीं, not queue, हम यहाँ पर queue utilize नहीं करेंगे. Instead this is a greedy method, so we'll be using priority queue. That means ऑप्टिमल में हमें पहुंचना है, जितने मिनिमम डिस्टेंस हो वी विल बी सिलेक्टिंग द मोस्ट मिनिमम वन. सो दिस इज क्यू प्लस ग्रेडी. दिस इज बीइंग अप्लाइड इन Dijkstra. That's what we'll be using here. We'll be using here priority queue. Okay, and now notice one thing, that whenever we are reaching from this position to this position, so it might have a weight like 5. So okay, we'll be observing the next. So just notice that 0. Here 0 is connected with 2 points. This is 1 connected with 1. This is 2. So 1 has, if we try to reach, मतलब अगर हम 0 से 1 तक reach करने की कोशिश करेंगे, 0 से 1 तक, then we have a weight of 2. That means it is having, if we try to reach from 0 to 1, then we have a 1 and we have a weight of 2. If we try to reach from 0 to 2, this is having weight of 4. 0 to 2, that it is having a weight of 4. That means we have to create nodes like this. हम अभी जो node create करेंगे, मतलब previously what we have done to create a node, simply if we just declare like this integer node, so this node would be possible. हम ऐसे इस node को create कर देते 0, but now we cannot create like this. We have to use the node and its age and its weight, because every time there is a weight section. So how we can create it? For that we'll be creating a node class. So let's create a node. Okay, let's take it to site. So now we'll be representing the node class. So it's like this. So if you notice the node, every node that is having the node data part and the weight part, so we can represent the node like this: class node, and this node is having two parts. First, this is 0, this data part, so this is, let's call it integer node, and second is also having a weight, so let's call it integer weight. And now we will be creating a constructor to initialize all those two. So public node integer weight. So this dot node equals to node, and this dot weight equals to weight. So by now we have created the node class. First we have declared the variables, and then we have initialized everyone inside the constructor. Now we have to create a Dijkstra algorithm. So in first Dijkstra algorithm, what we do, we have to create the graph. We have to create this graph, and for this graph we can represent using adjacency list. So we'll be first creating the class graph. So let's call it graph Dijkstra. Class graph Dijkstra. So we call it class graph Dijkstra. And now first we need to declare the number of vertices. That means with how many vertices we want to create. So if you notice, there are 1, 2, 3, 4, 5, 6. So number of vertices we can call it, that is equals to 6. So we'll be creating this variable, private integer number of vertices. Private integer number of vertices. Right now just notice, we are just constructing. In here we have constructed this node. By declaring this node, we have constructed this node 0, and if it's pointing to someone, then it is having this value. That means this weight part is denoting to this, and this node part is denoting to this. So by now declaring this code, we have constructed this part. So in the second part we do this. Now what we do, we try to create this entire graph using adjacency list. हम यहाँ पर adjacency list को यूज करेंगे इस ग्राफ को रिप्रेजेंट करने के लिए. So let's declare the adjacency list. Private integer number of, what is this? So this is private integer number of nodes. or number of vertices. So this is number of vertices. Okay. Now we'll be representing it with the help of adjacency list. So adjacency list will have that type of structure. That means it will be a list, and this list will have list. These are also list, and those list will have integers. So private list will contain list, and those list will contain integer, and we call it adjacency list. Adjacency list. Okay. So now we will be initializing those utilizing the constructor, that is graph Dijkstra. Graph Dijkstra. And graph Dijkstra, so integer number of vertices. Integer number of vertices. So now we will be initializing this dot number of vertices. This dot number of vertices. So this dot number of vertices, that will be equals to number of vertices. Okay, so now we have initialized the number of vertices. Now we'll be initializing this adjacency list. So adjacency list, that is equals to new array list, and we'll be creating spaces for all those number of vertices. So number of vertices. So it will be creating for all those. Now we created the array list like this. And now we'll be initializing array list inside this array list for all the number of vertices. That means we'll be using a loop for I equals to 0 to all the number of vertices. So let's create a loop. So for integer, let's use another color. For integer I equals to 0, I less than number of vertices, and I plus plus. So for every in adjacency list, we will be adding for all the indexes. So let's add using the white color. Adjacency list dot add, and now we are adding an array list, new array list. So by now we have added array list for all the adjacency, and now we have declared the entire constructor. So okay, now through this graph line, if you notice this graph line, so first we have declared the number of vertices, that means this number of vertices 6, we have declared it. List of integers. Now for representing this graph, you know that हमें एक adjacency list create करना पड़ता है, and this is the representation of adjacency list. अब इसी adjacency list के अंदर हमने धीरे we have created this space, then we have created this space, I equals to 0 to 1 to 2. For every number of items we have created spaces in here. Got it? So this is the graph creation that we first create graph Dijkstra. Now the second portion is we have to add those edges. Look, we have created the node, we have created this list. List for those. We have created those adjacency list representation for each node. And now it will have two values, a value of their integer part and the value of this weight. Okay, so we have created that portion. Now we have to add those edges. Like this. We have to add those edges. So now we have to create function for adding edges. So let's call it public void add edge. So now we'll be creating function public void add edge. So we'll be creating function public void add edge. Public void add edge. And now we'll be passing from where we want to add. Let's suppose this is u, and we want to add with v, and we will have a weight. So we have to pass three variables here. We have to pass the u from where we'll be starting. Then we have to pass the second vertices, that is integer v, where we want to add, and we have to add the weight that we actually want to add. So simply let's write it. Adjacency list dot get of u. First, the list we have created, we will be trying to get everything from here, the u portion. So for that we'll be writing adjacency list dot get of u. So once we write, we'll be getting the entire list from here, dot get of u. and now we'll be adding v with this. So we'll be add. And how we can add v? We have to add v in terms of node. So we had a node structure like this, which has a data integer data part, and the another portion was weight part. So add new node. We have to add as a new node object, new node, and the node part will contain the v. Oh, sorry, you haven't passed the values here. So this is integer u, and then we'll be passing the integer v, and then we'll be passing the integer w. Wait, so okay, now this starts. So new node, and then we'll be passing this u. We have added u, then v comma w, this weight. So vw. So now a node will get added, a node will be getting added. So now we have added, suppose this is the relationship, that is the relationship. So we have added, if this is u and this is v, so we have added for this like this. And if this is not single rated, that means this is unrated like this. If this is unrated like this, then we have to add from this side also, that if we traverse from this side or this side, the cost is similar 3. So we'll be adding for that also. So adjacency list dot get of v dot add new node. Now we'll be adding v comma w. So we have added this one, and now if you just notice the representation, that the representation will be like this. So let's say we are noticing for this 2. So if you notice the adjacency of 2, so the adjacency of 2 is 0. So 0 will be 0 comma, let's say this is 4, so 0 comma 4, and this 4 is at a distance of, let's say, 5, so this will be 4 comma 5. This 5 is, let's say, at a distance 150, so that will be 5 comma 150. That means in this way it will have a adjacency list representation. So like this, and this is the adjacency list, that type of representation. Okay, so that was the added function. Now this is graph Dijkstra class. So if you notice the graph Dijkstra, मतलब ये जो graph Dijkstra है और वो मतलब जो last one that we have studied, what was that? Shortest path algorithm. दोनों में सिर्फ एक ही डिस्टेंस है कि this is a mode like greedy algorithm. Greedy मतलब हम इसमें the most minimum को select करेंगे. If दिस इज आवर कीवी, सो कीवी में हम क्या करते थे, नॉर्मल एल्गोरिथम में जो भी फ्रंट में होते थे 0 1 2, तो हम 0 को पोल करते थे. लेकिन यहाँ पे लेट्स से देयर इज 10 इन द फ्रंट 10, सो हम यहाँ पे इन डिक्स्ट्रा में हम द मोस्ट मिनिमम 1 को विल बी एक्सट्रैक्टिंग ओनली दिस, विल बी एक्सट्रैक्टिंग 1, दैट मीन्स द मोस्ट मिनिमम 1, मोस्ट मिनिमम. और इस रीजन से विल बी यूटिलाइजिंग हियर द प्रायोरिटी क्यू, विल बी यूजिंग प्रायोरिटी क्यू. To give priority always to the most minimum one, we'll be using priority queue. So that is the important things to note here. And this is similar like we'll be creating a function public void Dijkstra. So let's create the function public void Dijkstra. Public void Dijkstra, and we'll be starting with a start node. So public void Dijkstra integer start node. So we'll be starting with a start node. So what we do in the Dijkstra node, notice, suppose this is connected to this like this, and this is connected to this like this. So when we start from this position, it is initially 0. If we start from this position, and it will be infinity, 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 and these are all connected like this. So what it does, so if that is 3, so it will add those values, the weight of this, the weight of this 0th node, this 0, and this age, the weight of age. So it will add those value, and it will check if this is, I mean, if that is lesser, if that is lesser, the summation is lesser, then it will update this infinity by this 3. Got it? That means the case was that if there is 0 and there is 1, so initially if this value will be infinity, and this value will be 0, so let's say this is 5, the cost is 5. So in Dijkstra, this is u, this is v, and that is cost, or weight, we can call it weight also. So in Dijkstra we add those two, we add those, and u plus weight or cost, whatever. If this is less than v, if that is less than v, then we'll be updating this one to here. That means v will be u plus cost of path, that is from u to v, whatever the path. That means we'll be adding that one. So that is the main motto that we'll be checking here. Okay, so first we'll be doing these things. Okay, let me remove, and that got deleted. So first what we'll be doing, first this is visited, that is visited or distance, we call it distance here. So first we'll be creating a distance array or distance anything, and we'll be initializing this a distance array with infinity, 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 infinity. So let's create a distance array first, and then we'll be initializing it with an infinity. Then we'll be creating a priority queue. This is priority queue, and in priority queue we will be inserting all those elements. We'll be inserting the start node, then we'll be polling. Then for, let's say, the current insertion node will be 0. For 0 we'll be again checking the nearest neighbor as same, and we'll be checking that feasibility condition. If d of u plus cost less than d of v, we'll be checking this condition. If that condition satisfies, then we'll be updating d of v by the value of d of u plus cost. Got it? So let's implement this in details. So first what we'll be creating, we'll be creating the distance array. So integer distance, new integer number of vertices. So now we have created the distance. It has been created now. So now we have created all the numbers also. We have to fill it with 0. So arrays. So we'll be using the method of arrays.fill method. So arrays.fill, and this is a distance array. Distance will be filling with infinity. That means integer dot max value, integer dot max value. So once you apply integer dot max value, it will be filled with infinity value. That means the maximum value. So now this is our filled with maximum value. Now we'll be updating the distance of source as 0. So if let's say this is the source, that is the source, then third 0, 1, 2, 3, this will get updated by 0 value. That will get updated by 0 value. So let's update the value. So distance of source, this array distance. So distance of source. This source is getting updated by 0. Okay, it got updated by 0. Now we'll be creating a priority queue. This priority queue we need to create. So let's create this priority queue. Priority queue. Priority queue. And this priority queue will be storing the node, this node, that class we have created. So priority queue node. And whenever we create a priority queue, we call the object name as minimum heap. So we'll be calling minimum heap queuing for better understanding purpose. Minimum heap queue. And now this is a new priority queue. So we'll be initializing like this, new priority queue. New priority queue. Okay, so this is new priority queue that we have created. So we are creating for how many spaces? We will be creating for all the number of vertices. So we'll be passing number of vertices. So we have passed number of vertices. Now we want to compare with respect to some any item. So for that we'll be using the comparator dot comparing integer. So comparator dot comparing integer, and now it will be comparing with respect to some attribute. So we'll be taking any attribute n to n dot weight. So we'll be actually comparing with respect to the weights. The weight. So we'll be comparing with respect to the weight. So n dot weight, and now it will, yeah, it will be stored by comparing one by one. So once we have done, now we'll be adding. We'll be adding the start node. What is the start node? Distance. Oh, sorry. This is not source. That is distance of start node. This is distance of start node. So now we'll be adding into our this priority queue, minimum heap queue. So we'll be adding this node, start node, into minimum heap queue. So let's add minimum heap queue, minimum heap queue dot add of start node. So we added to start node. So once we have added to a start node, now we can check. Now we'll be able to check the graph. So minimum heap dot add of start node. Sorry, we cannot add this start node like this. We have to add as also data. We have to add it also like node, new node. So start node and comma. We have to pass whatever the weight is with the start node. So the start node is always 0, so we'll be passing 0. So okay, we pass the 0. Because it doesn't matter from where we start, the initial value of this will always be 0 from 0 to 0. From 0 to 0 distance is always 0, so we'll be passing 0. Okay, so by now we have added into heap queue. That means start node, let's say 0 is the start node, it has been added into the queue. So now we'll be checking if queue is not empty. So while not of queue dot is empty, while not of minimum heap queue, if not of minimum heap queue dot is empty, that means if minimum heap queue is not empty, if that is not empty, then we'll be checking the feasibility condition, then we'll be checking the feasibility condition. So first we'll be polling. So if that is not empty, we'll be polling this item back from here. So integer, and we'll be polling. We cannot poll like this, we have to poll like node person. So we'll be polling like node current node, node current node, that is minimum heap queue dot poll. So we actually polled this node. These are stored in node structure. So poll like this, and now we'll be destructuring the data part. Integer current node. Sorry, integer current node. Let's call it just node. Integer node, that is equals to current node dot node. That means we are accessing the data portion. Where is our class? So you can see we have stored the data as node, this node. That's why we will be writing the node portion. So okay, let's move. So now we have destructured the integer node, current node dot node. So we have destructured the current node, and with respect to this current node, we'll be checking all the neighbors. So for we can check it is having those neighbors. So we'll be checking those neighbors, that for integer neighbor, for integer neighbor. So actually the neighbors will also be stored, the neighbors will also be stored as node. So instead of integer, we'll be calling them node. So node of neighbor in the adjacency list. So we'll be extracting all the data from the adjacency list. So we'll be writing adjacency list dot get of you. So adjacency list dot get, and we'll be simply getting all the data with respect to this initial node. So okay, now we'll be getting all the data. Now we'll be checking the feasibility condition. That means the condition. So now we have gotten the neighbor. That means we'll be getting this neighbor node like this, and it will also have a data post. It will also have a data portion which is called node, and a weight portion weight. So it will have that. So we'll be extracting those portion, that is integer v, and let's call it for our understanding integer u. So integer v, and this is neighbor.node, that means the data portion, the data 2 portion, neighbor.node. And we'll be also extracting the integer weight portion. So integer weight, that is neighbor.node. Okay, so now we have destructured the node portion. Now we'll be checking the feasibility condition. So we'll be checking if the distance, let's say this distance u to v, so we'll be checking this mathematical term and weight portion, that u plus v is less than v, then we'll be updating that one like this. So let's check if distance of u plus distance, if whatever the distance that was stored in u, distance of u plus weight, this weight is less than distance of v, that is less than distance of v, then we'll be updating the distance of v by distance of u plus weight. Okay, then we'll be updating the distance, and once you update the distance like this, Okay, we'll be updating the distance. Once this distance has been updated, we'll be adding the new v. That means this neighbor what we have extracted. We'll be adding this one with the updated distance. So we'll be adding like this minimum heap q. So this is the neighbor. We'll be adding the neighbor, but with the updated weight. We'll be adding. So minimum heap q dot add. We'll be adding v comma v, that is the vertex with respect to the distance that got stored in v, that is this updated distance. We'll be adding this one. So this will again add a new node v node here. So let's say the v was 1, so 1 will be getting added, then 2 will be getting added, like this. So now we end the line here. So once this program is executed, now we'll be printing the graph. So now we have to print entire graph, and for that we'll be simply writing system.out.println. So let's write system dot out dot println. So we'll be simply printing this graph shortest path from source. Shortest path from source. And then we'll be just writing like source. So this is source, that means this is the start node. So now we'll be printing all the vertices that the distance is present. So let's write a for loop for this. For integer I equals to 0, I less than number of vertices I plus plus. And now we'll be printing the distance system dot out dot print distance of I. So we'll be printing the distance plus few arrow to for better understanding purpose. So okay, and now we have to call the function from the main function. So for that we'll be simply declaring a void main function. So let's create a public static void main. Public static void main string of, and first that was I think graph Dijkstra. So we'll be creating our object with respect to graph Dijkstra g, that is equals to new graph Dijkstra. Okay, so we have created new graph Dijkstra object. So with respect to that object g dot add age, we need to add age. So we need to see that what are the ages we added. So in age I think we added 3 was the age probably for Dijkstra. So we have added u, v and weight. So we have to pass all those three arguments. So we'll be passing all those three arguments. Let's say we want to add this 0 and 1. Let's say we want to add this 0 and 1. So we'll be passing the 0, then 1, and the weight 3. So we'll be adding 0 and 3. Suppose we want to add 0 and 2, but with 5 weight, then z dot add age 0, 2, 5. Suppose you want to add this one with a distance of 10. So g dot add age 0, 5, 10. So okay, these are all the distances that I have added. So this is, and now to run the program we can just print g dot print graph. So I think we haven't created this print graph public void. So we haven't created the print graph function. If we would want to represent the print graph, we could create the print graph function, not important. So simply g dot Dijkstra, and we'll be passing start node. Let's want to pass this phone node. So we'll be passing 4 as the start node, and the program will get being executed. So if we just execute this program, we will be able to understand the Dijkstra algorithm. So by now we have understood the Dijkstra algorithm, the concept, and mainly the programming logic. So in next video session, we'll be moving that section. So if negative would come in here, the Dijkstra algorithm will fail. So for that, in the next lesson, we'll be observing the Belmont-Ford algorithm. So till then, okay, thanks. We're meeting in the next session.